Okay, so this is where we left off on Friday. So why don't you just re-familiarize yourself with this problem and then answer the question. So talk to the person next to you. What's going on here? What's the, we said this was F here. Which was, did I say x plus 2? You have to pretend that's straight, right? That's a line. Pretend that's straight. And this one is g of x is the x squared. So just take a minute, refamiliarize yourself. So where's the axis? What's the empty shell? How are we rotating the region to get the empty shell? And what is the empty shell? Which rate are we going to use as the cylinders grow? Are we going to use area of the base or 2 pi RH, area of the lateral surface? And then what's the independent variable, x or y? So take 1 minute. Everyone's talking to somebody. Talk through this situation. Go. Everybody's talking to somebody. You got them. If you have to move, you have to move.
Because if you use 2 pi RH, you like don't want to get out of this stuff. You just get like
It's not how you feel. It's not how you feel. It's is the height growing or is the radius growing? That determines what the answer is. Is the height growing or is the radius growing? Therefore, it is. Yeah. I mean, the best is if you're able to print them from GC, but if you can't, if it's like not feasible or super convenient, then a good sketch is okay. Okay. What is our axis of rotation? What is our axis of rotation? Y-axis. How do we write the y-axis mathematically? Y-axis is the same as? Y equals 0, right? Is that right? X equals 0. Calculus students through the ages have done this. Don't be one of them. Y equals 0 is what? All points that have a y coordinate of 0 or x-axis. So if it's the y-axis, we've got x equals 0. This is a huge stumbling block. If part of your region is x equals 0, that's the y-axis. If you're revolving around x equals 0, that's the y-axis. Okay? It's all points with an x coordinate of 0. All right. So now we've got we're rotating that thing around the y-axis, and we get these are our typical shells. Okay, so what's our independent variable, x or y? Where are we using independent variable, x or y? How do you know? Yeah, we're increasing y through delta y intervals. That's what this is showing you. We're increasing y through delta y intervals. Okay? So now looking at these typical cylinders that we're going to fill up this empty shell with, we're going to fill up the empty shell with these typical cylinders. Is the rate of change going to be area of the base or 2 pi RH? I'm hearing both. Is it area of the base or 2 pi RH? How do you answer that question? You say, are these cylinders growing in height or are they growing in radius in the current interval? In the current interval, are they growing in height or are they growing in radius? Height. Therefore, Area of the base. If the cylinders grow in height in the current interval, then you use area of the base as the rate. Okay? And then but we said there was something special about this problem. Remember that at the end of last time? What's special about this problem? So when y is low, like around 0 or 1, what kind of cylinders do we have? Filled, right? I call them pancakes, okay? I call them pancakes. With blue syrup. Okay? But then when you get y passes y equals 2, then what do you have? Washers, right? They're like washer type cylinders. You got a hole in the middle, which means our rate changes, right? The rate of change function is still area of the base, but our base is first solid, and then you get to y equals 2, and then there's a hole. So we need, for this rate function, we need 2 rates, right? So the first rate is going to be pi r squared, right? Pancakes, the pancakes is pi r squared. Just the there's a good one. All right. So the question is now then, what is r? If we're doing pi r squared, what is r? Is it an x coordinate, a y coordinate, a big change in x, or a big change in y? What is the radius? The radius is from here to there. X coordinate, y coordinate, big change in x, big change in y. X coordinate. Distance from the y-axis to a function is just the x coordinate, right? So it's just x. So we'll have pi, our rate will be pi x squared. Pi times radius squared, which is pi times x squared. But our function is in terms of what? Y. So that's the same as pi times. Well, look. Our function is x squared. So what is x squared in terms of y? It's just y, right? Or you could solve for it. Right? You say y equals x squared, and then you say x equals the square root of y, and then you come back here and you square it, so you're back to y again. Okay? Same thing. All right, and then we get to, so that's from y equals 0 to 2, right? And then we get to 2 from 2 to 4, and now we've got washers. But we're still doing area of the base. Okay. There's a good one. All right, now we're doing washers. And so area of the base is what? What's area of the base? Pi r outer squared minus pi r inner squared, right? We got to subtract out the whole now. So the question is, the outer radius, is it an x coordinate, y coordinate, big change in x, or big change in y? X coordinate of g, right? G of x is x squared. And we already did that, right? That's just pi y. Minus, this is squared. Now what's this? This radius, the inner radius. X coordinate, y coordinate, big change in x, or big change in y? Another x coordinate, but it's just the f function, right? So we got y equals x plus 2. And we know this is still, the radius is x, so it's going to be pi times x squared. So what is x squared in terms of y? So if y equals x plus 2, then x equals y minus 2. That's my x, and that's my radius. And then the area of the inner circle is going to be pi times radius squared, or pi times y minus 2 quantity squared. Okay, I did that fast. If I lost you, please ask. But that's pi r squared. The inner radius is the x coordinate. That x coordinate is according to f. The radius is x, so according to f, x is y minus 2. So it's pi times radius pi, y minus 2 squared. So there's a rate function. piecewise rate. And so then we're going to have piecewise volume as well. So the volume as a function of y is going to be from 0 to 2. And from 2 to 4. So what will my volume be from 0 to 2? That should be easy. Everyone should be able to write that down. What's my volume accumulation function as y goes from 0 to 2? Meaning this part right here. Accumulating volume up to 2. How would I write that? We said all we needed to write an accumulation function now was the rate. So we can write any accumulation function we want. What's the key here? What's the structure? Integral. Integral, right? Integral from 0 to y of. We did all this hard work to call it r sub v. So let's use that. I can just write down what? R sub v of, not y, t dt. When y is between 0 and 2. And because when y is between 0 and 2, it's going to go to this part of the rate function. Right? It's going to give us the right part of the rate function. Okay? And then I want to continue having this be an accumulation function from y equals 0. So when I'm accumulating these washers, I still want to include all the volume I got before, right? I'm accumulating still from y equals 0. We want an accumulation function all the way up. Which means, for the second part, I'm going to do v of 2. All the volume I got from the first part, right? All the volume I accumulated from the pancakes plus integral from 2 to y, not 2 to 4, 2 to y. It's a function, right? I want every y along the way. 2 to y of what? I only got a little bit of room. How can I do it? R sub v of t dt. And how will it know to pick this rate function? Because y is between 2 and 4, and when y is between 2 and 4, you pick this rate function. That's what this rate function says. See that? So we did all this hard work to write out the rate function very explicitly, and we called it r sub v of y. So use function notation. Don't write all that again. Just use it. You did the hard work, so use the hard work that you did. Don't rewrite all that stuff. And GC, it's the language of math, GC knows it too. So if you define in one line of GC, if you define the rate function, call it according to its name. In another line, you can use function notation to reference it, and it'll know exactly what you want. Or it'll do exactly what you want if you've put it in correctly. All right, questions on that example? Really good, lots of good stuff in there. Yes, please.
Does the accumulation function have to be piecewise since the rate function is already a piecewise function?
Yes, because we need to use this part of this rate from 0 to 2 and this rate, right? So let me think about that. Would it do that automatically? No, yes, you do need to do it piecewise, because if you just put this from 0 to 4, or 0 to y, I'd have to think about that. Do it this way. But I don't think it'll work, but I just on the spot I just can't think of it. Yeah.
Why is it that you have to account for what's already accumulated with the volume?
Because if I put in y equals 3, what do I want? I want all the volume that I got in this filled up shell up from y to 3.
But doesn't the first part already account for that?
No, it doesn't. But I'm putting in y equals 3. If I put y equals 3 into this function, it's going to come here, and it's going to evaluate that integral from 2 to y of the rate. So you need all that volume from before. Yeah. Other questions? Yes?
When do we have to solve for x with the functions?
Okay, so this function is in terms of y. So everything has to be in terms of y. So we had x coordinates as our radius. So according to pi r squared, it was pi x squared. But this function is in terms of y. So when you have x's in your rate function and your independent variable is y, that's when you need x in terms of y. Other way around also. If you have y's in your rate function, but your rate function is in terms of x, then you need to solve x in terms of y. Okay, new example. Well, just briefly, I want to just look at this. What's different about this? So what's the axis of rotation now? What's the axis of rotation of the region to form the shell? Is this a different shell being filled or the same shell being filled? The shell, the empty shell. Different shell or same shell? Same shell, exact same shell. We're taking that region and rotating about the y-axis. It's the exact same empty shell. All right, but what's different now? Okay, but before even that, so how am I approaching the problem differently? What's the overall approach that's different now to filling that empty shell? Yeah. Right, now we're using x as the independent variable, and we're letting x increase through delta x intervals, right? So this results in cylinders that change in height or change in radius in the current interval. Radius, we're going to do 2 pi rh. But then what do you notice about this problem that's different than the previous one? Okay, it has the shells that grow in radius, that's true. Well, but there's a huge fundamental difference between solving the previous problem and solving this problem. Overall, yeah.
This one, it's easier because you don't have to subtract anything.
It's easier because why? Is it piecewise? Is this piecewise? It's not piecewise. We have the same typical cylinders the whole way. We have the same typical cylinders growing in radius the whole way. So if you had a choice, maybe this would be, it's less work to have a accumulation function. I mean, now you're responsible for knowing how to do it both ways. But if you had the choice, you want to do the most efficient way, this doesn't require piecewise. All the cylinders are the same. Does it make sense? Okay, new example. Now you're going to do all the work. No more animations to help you. So the first goal here is we're going to sketch the region in the first quadrant bounded by these 3 mathematical statements. Got to get this right before we can do anything else. So y equals 1/4 x squared plus 2, x equals 2, and y equals 6. So first the region in the plane. Can you sketch it? So this is somewhat tricky because when you draw these, you get all kinds of different possible regions, like a patchwork quilt, okay? You got to figure out there's only one region that's bounded by these 3 things. Let me see your paper. Good. So we got it. So x equals 2 is what kind of line, Zoe? Vertical line. Vertical line at x equals 2. What about y equals 6? What's that like? Okay, and what about 1/4 x squared plus 2?
It's a
Parabola.
The minimum is at y equals 2.
Okay. Parabola with minimum y equals 2. Very good. So, what's the region we're talking about? What's the region that we're talking about? So is it this? How would it be this? if you also had what? Y equals 0? X equals 0, right? The y-axis. So if it said the y-axis or x equals 0, then we'd be talking about this. But it doesn't say the y-axis or x equals 0, so it's not this. Is it down here? Same thing. That doesn't have y equals 0 or x equals 0, right? Which are both in there. And it also doesn't use y equals 6. So, somewhere I put, there it is. That's the only region that has exactly those three as its boundaries. Right? It's the only region of every region you could pick on the screen right now. It's the only one that has those three as its boundaries. It doesn't say x or y axis. Doesn't say x equals 0, y equals 0. Okay. We're going to, now I want you to sketch the empty shell formed when the edge of the region, the black perimeter, is revolved about the line y equals 1. We're going to sketch the empty shell, no cylinders yet. Sketch the empty shell that you get when this region, the perimeter of this region is rotated about y equals 1. Go. So no animations to help now. Got to be able to do it. Make sure you get y equals 1 right. Make sure you have, what is y equals 1? What is that? What kind of thing is that? Horizontal or vertical line? Horizontal. Y equals 1. So we're going to rotate that around y equals 1, and we're trying to figure out what the empty shell that we're going to get is. The empty shell. Is that what you at least imagined and did your best to draw? So what are we filling up? Are we filling up the funnel? Or are we filling up the outside part? Yeah, this is just space, right? This is just open space. So like air and water can go right through that. What we're going to fill up is we're going to fill up all this part. Like it's like a, I don't know, a weird toilet paper roll or something. And the solid we're going to fill is actually the toilet paper, right? But it's got this weird funnel middle thing, right? Okay, questions on that? All right, let's go on here. So now we're gonna start with x. We're gonna imagine x increasing through delta x intervals to form right cylinders that fill this empty shell. So can you imagine x increasing through delta x intervals to form right cylinders that form the shell? That's what we're going to do. Can you imagine that? And we'll just do 3. Let's just do 3 A and B here. So once you've imagined typical cylinders with x, as x increases through delta x intervals forming right cylinders to fill that shell, draw a typical cylinder. As it grows in volume in some delta x interval, and that will be like the current interval, so a typical delta x, typical cylinder, and then find the rate of change of volume with respect to that independent variable x. So you got some work to do now. Is the task clear? You're either making progress or you're getting help. No sitting back waiting for other students or me to talk about it. Everyone's working at this. Go. So with x varying through delta x intervals, this is what's going to form the cylinder that we're going to fill with. So what will that cylinder look like? It'll be a washer. Flat, horizontally, or standing up on end? It's going to be a vertical washer standing up on end, so it'll look like this. Small version of it. I don't want to draw it on here, it'll make a mess. So I'll just make a small one. This. I'll try again. Give myself more room. There we go. There we go. That's what a typical cylinder is going to look like. A washer standing up on end as x increases through delta x intervals. So will these be growing in radius or in height? Are they growing in radius or height in the current interval as we fill this shell up with cylinders? Height. Height is increasing. X is increasing, so the height increases. Therefore, rate of change of volume with respect to x is going to be area of the base or 2 pi RH? Area of the base. Height is growing. Height is growing, so it's going to be this area right here. It's going to be our rate function. So it'll be pi r outer squared minus pi r inner squared, because it's a washer, right? It's got a hole in it. So that's going to be our rate function structure. So now we got to figure out these radii. So the outer radius. The outer radius is from the center of rotation up to the wherever the outside of the cylinder is, up here. So is that an x coordinate, a y coordinate, a big change in x, or a big change in y? The outer radius. Is it a y coordinate? No, it's not a y coordinate because it's from the center of rotation, which is at y equals 1. So what is that distance right there? That's our radius of their outer radius of our typical. It's not a y coordinate. It uses y coordinates, but what is it? This is what I'm talking about when I say a big change in y. So to calculate a big change in y, we need that distance right there. How do you calculate that distance? Y final minus y initial. What's y final? 6. What's y initial? The radius of every one of these is, the outer radius? 5, not 6, because the center of rotation is 1. So this is what I mean by a big change in y. And to calculate that, you do y final minus y initial. Therefore, we have pi times radius is, outer radius, 5. A big change in y. Minus our inner. So what's our inner? An x coordinate, a y coordinate, a big change in x, or a big change in y? Another big change in y. This is from here to here, right? So now our inner radius is still from y equals 1 to the curve. So to get a big change in y, we calculate y final minus y initial. What's y final? The function, right? F of x. Okay? So it's going to be, I'll just write y, then minus y initial, which is 1. But our rate function is in terms of, our independent variable is x. So we got to change all our y's to x's because our independent variable is x. So what is y in terms of x? For the curve. So that's the y value of the curve, right? Which is 1/4 x squared plus 2. That whole thing is squared. That's the radius, so that whole inner radius, whole thing is squared. Okay, did I lose you? Does it make sense? Yeah.
Should we simplify that to 1/4 x squared plus
Sure.
1?
Yeah. Does it make sense? Volume accumulation function in terms of x is integral from 2, right? So x values, our starting x value to start accumulating now is 2, not 0. So 2 to x of RV t dt, where RVx is this thing. Don't forget the square. Pi r squared, pi r outer squared minus pi r inner squared. So what? Or you could rewrite. If you want to rewrite this thing, simplify it, and you write it in terms of t, that's fine. But we called it a function. We called it RVx. Let's use it, right? Use function notation. Super convenient. Okay, questions on that? All right, now we're going to let y change through delta y intervals. Let y, same region, the yellow region, same rotation around the line y equals 1, but now let y vary through delta y intervals, and start again. Same thing, right? Draw a typical, do number 3, again, as y increases through delta y intervals. Yep. If you have a question on this number 3 that we just did, catch one of us as we work around. But if you're good on that, then redo number 3, y increasing through delta y intervals. Here's typical cylinder. Is that what you got? Same shell. We're changing y through y intervals. So you get cylinders like this now. Sleeves. Sleeves, okay? Do these grow in height or radius as y increases in the current interval? Radius. These grow in radius. Height stays constant in the current interval. Therefore, rate function is 2 pi RH. So all we need is r and h in terms of y. What's the radius? Is it a y-coordinate? That's the radius of the cylinder. Y-coordinate, x-coordinate, big change in x or big change in y? Big change in y. Okay? And what is that big change in y? Y final minus y initial. Y final is? It's just simply the y-coordinate, right? That is the y-coordinate. We said y is increasing through delta y intervals, so there's some current value of y. That's what y final for this radius is. It's y. But that's not the radius. The radius would be y minus 1. Height of these is? X-coordinate, y-coordinate, big change in x or big change in y? Big change in x, right? That's a big change in x. So we do x final minus x initial. So the question is, let's do x initial first. That's easy. What's x initial? 2. What's x final? X final is according to this right here. So this is where I got y equals 1/4 x squared plus 2. I need this to be in terms of y, because our function is y. So what do I need to do? I need to solve this. I need the x-coordinate there, but in terms of y. So it's going to be y minus 2 times 4 equals x squared, so square root. It's going to be 4 times square root of 4 times y minus 2. What is that? That's the x-coordinate of points on this curve expressed in terms of y. There's your rate function. Don't just jot it down and get out of here. Make sure you understand it. I'll leave it up if you want to ask me on the way out.